All right. Good morning. Today's lesson is in Unit 5. It's SAS 2. Yesterday we did Unit 4's SAS 2. Today we're going to compare linear and exponential functions. It's a real quick lesson. Shouldn't be too hard to understand. So let's look at this bell ringer. Cohen sells magazine subscriptions. He's paid $20 to start selling, and then he earns $1.50 for each subscription he sells. The table shows the amount of money M Cohen earns for selling N subscription. What is the rate of change of the data represented in the table? And how does the problem change in Cohen's earnings grow exponentially? If Cohen's earnings grow exponentially. And what does that mean in the context of the situation? Well, if you think about it, yesterday when we did this assignment, we talked about how this was actually common differences. So the rate of change is the common difference, and that's how it works. So back to that problem. If it's an exponential problem, we don't have a common difference. We have something else common. This doesn't change by one number. It changes by different numbers every time, and it has to do with multiplication. We'll talk about that in a minute. All right, good things. Good things is it's Wednesday. I'm working on the assignment for Thursday, and we're going to get through this semester quickly, a lot quicker than you guys may anticipate or believe, so just hang in there. It'll be done before you know it. And the next thing you know, you'll be 40 looking back at this as the glory days. Anyway, in previous work, you wrote the linear function rule describing the amount of money Cohen earns as a function of the number of subscriptions he sells. What do the domain and range of the situation represent? Let's take a look at that. The domain represents the number of magazines he sells, and the range represents the amount of money Cohen earns. And we can fill in these blanks to show the differences between the given entries in the table. For each table, we'll make a statement summarizing the relationship between changes in the domain and changes in the range. So the change in N is 1, and the change in M is 150. Still, the change between 1 and 2 is just 1. The change between 21.50 and 23 is $1.50. And as you can see, as N goes up by 1, M goes up by $1.50. So adding 1 unit to the domain leads to adding 1.5 units to the range. These changes are called first differences. All right, let's consider Cohen's earnings potential based on the number of subscriptions he sells. What is the domain and range for this table? The domain is 0 to infinity, the number of subscriptions, and the range from 20 to infinity dollars. Let me move this out of the way so you can see it. Absolutely, he can make an unlimited amount of money, and that's just the way it works. So let's move on. Fill in the blanks and find the difference between the given entries in the table. For each table, make a statement summarizing the relationship between changes in the domain and changes in the range. Okay, so let's look. 2 between 0 and 2, and 3 between $20 and $23. 2 between 2 and 4, and 3 between $23 and $6. We still get the same answer. Adding 2 units to the domain leads to adding 3 units to the range. It's the same thing, 2 to 3 or 1 to 1.5. Suppose Cohen's earning structure changed so that for every magazine subscription he sold, he made 1.5 times his previous earnings. Again, assume that he starts with $20 for 0 subscriptions sold. What does Cohen's earning table look like? So for 0, he would have $20. For 1, he would have 20 times 1.5, which is 30. For 2 subscriptions, it's 30 times 1.5 or 45. For 3 subscriptions, it would be 45 times 1.5 or 67.50. And for 4 subscriptions, it's 67.50 times 1.5 or 101.25. Now, obviously, he's going to make a lot more money by using that particular compensation package. So in his first earning situation, changes in the domain values and their impact on the values in the range. We analyze them. Now we're going to analyze the new data set you found in question 3, this last question we just looked at. Does the data show the same kind of add-add relationship as in the linear relationship in Cohen's new earnings situation? The effect on values need to be described, and the range for this new set of data value when values in the domain are changed incrementally by adding 1. Is the relationship the same when adding 2 to each domain value? How about adding 5? Actually, adding 1 to the unit values in domain leads to multiplying values in the range by 1.5. And we'd do the same thing. You had 2 would multiply by 1.5 to the second power. Adding 5 would be multiplying by 1.5 to the fifth power. And that's exactly what's going on here. All right. Describe a fundamental difference between linear and exponential functions based on a look at tables of values. How is the rate of change of a linear function different from the rate of change of an exponential function? All right. Well, the domain remains the same. The range, or the valuation to determine the sequence, changes dramatically. We call the change of a linear function as a rate of change in the exponential function. That change is not linear, or add. So it is not a rate of change. It's add multiply, so we call that a ratio of change. So that's exactly what it's called. So in an exponential function, it's a ratio of change. All right, I'm going to launch you with this, and we'll talk about this again. One of the reasons so many people invest so much of their money in the stock market is the potential for growth. Now, working only earns your money in a linear fashion. You work a number of hours, you get the same number of money per hour. You work a number of months, you get the same amount of money per month, depending on whether you're on wage or salaried income. So you work a certain amount of time, you earn a certain amount of money, right? Okay, so in the stock market, you invest a certain amount and you have the potential to earn an exponential amount in return. With every potential earning is a potential risk. There is a risk investing could lose money exponential. And that's the way you need to look at it. You've never looked into the stock market. The end of this semester, I'm going to try to get a simulation of the stock market so we can do it online and then maybe have a contest. And that'll help you guys see a little bit about the stock market. But in the meantime, don't forget, there's a lesson in the Google Classroom by the same name. Get that done today. In the meantime, be blessed and be a blessing.